This is Django Riffs, a podcast for learning web application development in Python using the Django web framework. We explore all of Django's features to equip you with the knowledge to build your own web app. I'm your host, Matt Lehman. Episode 7, Models and Managers and Querysets. Oh my! Hello and welcome back to Django Riffs. On this episode, we're going to talk about models and how to interact with your data in your database using models. On the last episode, we focused on the basics of setting up a database, creating your first model, working with migrations, and doing some of the preliminary steps that you're going to need to do in order to have your system be prepared to work with databases. But we didn't really go into the usage of models. We talked very briefly about what a model looks like and a little bit of structure around that, but we left it there because there's a lot of supporting stuff that has to go into making that work. But today we're going to dig into using those models and seeing all of the API that Django exposes to give you the tools you need to do that interaction. When you work with a model, there's a number of methods that you call on it that will issue commands to a database. So when you call, for instance, a save method on a Django model, what you're actually doing is issuing a command to the database to insert some data into the database. And these commands or messages, they are called queries. And they're called queries because databases that get used in Django are relational databases. They use the structured query language, SQL, to communicate with the actual database. And when you're working with a model, the model is really doing the translation into SQL queries to communicate to the database. So what does an SQL query look like? It's not terribly important to know this all the time because of the tools that Django provides, but it is good to have an idea that when you're working with a Django model, that something is going on under the covers and is doing extra work for you. Last episode, we talked about an employee model that had a first name, a last name, and a job title. And we showed an example of creating a model instance that had all those values filled in. And I said that it wasn't going to work at the time because we hadn't migrated, and that was the last topic that we covered. But assuming that you've actually migrated your application to use this new model, if you were to save your model instance, then Django would send some SQL query to the database that would actually do the insertion of that new model instance into the database. And that insertion looks like this. I call it an insertion because that is the command that gets issued. It's called an insert. And so there's some SQL. SQLs is sometimes called SQL. Some people hate that name, but I have trouble slipping in and out between SQL and SQL, so you might hear me call it SQL, and I'm not talking about a follow-on to a book. I'm talking about SQL queries. A SQL statement would look like this. It would say insert into application employee, which is the database table that we have. And then there are 3 different parameters that are specified, a first name, a last name, and a job title. And then there's a keyword of values followed by the actual values that we wanted to add. And our example last time was Tom Bombadil from Lord of the Rings, so we'll continue on that. So the values would be Tom Bombadil, and job title would be Old Forest Keeper. So that is the SQL statement that gets issued to the database to add it and store it permanently. The syntax that I'm describing here is a pretty vanilla circumstance, but you need to recognize that there can be some variance between different databases that you might use. So I'm going to use examples that work for the SQLite engine, that is for the SQLite database, and this might be a little different for Postgres or MySQL or SQL Server or Oracle, but you need to understand that they'll all be pretty similar because it is a fairly common standard, and we're not covering anything super esoteric in this episode. The nice part about this is that you don't actually need to know the query. You don't need to know the details in most circumstances. Django is taking care of that work for you on your behalf. And it does this by using a technology or pattern called an ORM. An ORM stands for an Object Relational Mapper. The idea is to translate an object, in this case a Python object, because that's the language that we're working with, to its relational equivalent. Remember that a database here, a SQL database, is considered a relational database. We're going to get into why later on in this episode, but that is just the term that gets used. So an object relational mapper is taking an object from a language like Python or Java or whatever language you happen to be working with and mapping it to its relational equivalent on the other side. The nice part about working with an object relational mapper, which is usually called an ORM, or some people like to use it as a phrase and say ORM, but I'm in the ORM camp, is that you get to work with Python code. You don't spend your time messing with SQL queries directly, and there's some advantages to that. There are some disadvantages too, because it does obfuscate the actual queries that get issued, and sometimes there are performance issues that can come up because of that. But I think in general, it gives itself a nice interface to working with, and one that feels very natural. So we saw that a model record can be called with a save method, and the ORM will do the translation into an insert call. But what else can we do? Well, we can do lots of other things. We can get all of the rows out of a database, or we could get a filtered set of rows out of the database based on some kind of filtering criteria that we want. We can update a collection of rows at the same time. We can also delete rows from the database. The ORM gives us tools to do all of those things, and we'll talk through some of them. Many of these operations that we see actually are not done directly through the model. Instead, Django uses something called a manager class that is associated with the model and gives you the language and the set of methods that you can use to do some of these broad set applications. A manager is attached to the model class as an attribute called objects by default. It is something that's configurable, and you can add extra managers, but when you create a Django model, it will add an objects attribute to the class. Let's look at an example where the manager gets used and how you access it. We're going to continue working with our employee model, and we're going to do from application.models import employee. And we're going to assume that we have a database table that has some data in it with some fictitious company. And we're going to work with Bobs, people named Bob, Robert. And it's just sort of a bunch of silly examples, but it should give you an idea of what each of these methods is doing. Our line is going to be the variable Bobs is equal to employee, the model name, dot objects, dot filter, which is a method, and that first argument to filter is going to be a keyword argument of first name equals Bob. And that's going to return a set of something in that Bob's variable that we can iterate over that is for Bob in Bob's, and then we can print out the stuff about Bob. And each of these Bob instances, each time the variable is iterated over in the loop, will be a employee instance. So that's the type. I really probably should have said for employee and employees or something to make this more generic, but it's more fun. And that'll print out some names. And the names that we're going to use are names of famous Bobs in entertainment, like Bob Ross, Bob Barker, Bob Marley, Bob Dylan, so on. Cool part about this set that came back, this Bob's value that we stored, is that you can access the query that the Django ORM is going to issue in order to collect that information. So if we are on the Python REPL, which is where this example has come from so far, and we print bobs.query, it is going to print out the SQL query that was sent to the database in order to get that information back into Python that you can work with it. And so that query is going to look like a select is the name of the query, and it's going to select a variety of rows and columns from the database. So it's going to ask for them specifically. So it's application employee ID, first name, last name, job title. All of these things are the columns that we're asking for. And then it says from application employee, that's the database table that we want. And then because we used a filter method in our example, there is something called a where clause. And the where clause is there to do the additional filtering on the rows. So we have where application employee first name is equal to Bob. that instructs the database engine to only return rows that match that condition. Let's break down this example a little bit and talk about the pieces that came back, because I was a little vague about them, but they are specific types. They correspond to specific classes. So as I said, the objects attribute on the employee was a model manager. And when you call the filter method, what you get returned back to you is something called a query set. Query set is a very versatile class that represents data that comes out of the database, and it matches to some set of rows in the database. And it's named query set because it corresponds to a SQL query. So what if you want to delete a record from the employee table? Another example is going to import the employee model again. And let's say we want to get rid of the Bob Barker record. So we can do a filter to get the right record. So employee.objects.filter, and then the parameters are first name equal Bob, last name equal Barker. That's going to close our filter. And then that would return a query set, and the query set has a delete method on it. We don't have to assign that to a variable. We can immediately call that query set. So we're going to chain it together with a .delete call at the end. And that'll do the work of going to the database, finding any records that match, and we're assuming in this case that it's only one record that will match, and it will delete the Bob Barker record from our database. So this is an instance where it only deletes one because I told you there's only one record, but that could have deleted a variety of records if there were multiple Bob Barkers in that company, for example. So that's proving that a query set can apply operations in bulk. And this is useful. It makes it convenient so that you don't have to loop over things and do things one at a time. You can send a single command and it will send a single SQL query, which will do operations efficiently. If you do them one query at a time, it actually turns out to be very inefficient. And that's actually one of the challenges with working with an ORM, is sometimes you don't know when you're being inefficient in issuing multiple queries. So you need to be knowledgeable about the methods and how they work, and know the right patterns to delete records. Because, for instance, you could iterate over a list from a query set and do like I did earlier with the 4 Bob and Bobs, and you could call delete on each one of those things, and it would delete the record, but it would send multiple SQL queries. And that's going to be slow, because when you think about the way the application needs to work, it is a Django web application communicating with a database. And that database is usually over a network, and so there's time that's involved to do that network communication. And that network communication is naturally a slow part of the whole process. Anytime you're doing I/O, input-output stuff like networking, it is naturally the slowest portions of your code execution. Let's talk about a number of query set methods that you'll encounter that I think are, at least in my point of view, very useful. They might not be all of the methods that you would use. For that, I would refer you to the Django documentation, which will describe all of the query set methods. But these are the ones that, if you master this list, you will get 80 or 90% of the value that the query set class has to offer. The first method to call out is create. In my earlier example of creating a model, we created a model instance directly, and we gave it all of the parameters. But you can also do this directly through the models manager. So we can say employee.objects.create and pass in keyword arguments of first name and last name of Bobby and tables, and create a record for ourselves in the database. That's an alternative method of creating records that you might sometimes use. The next method that I think you'll encounter pretty often is get. The unique part about get is that it's designed to return one and only one record. So if you do a get operation and the filtering criteria that you give it would give you multiple records, then Django is actually going to raise an exception and say, that's confusing, you need to be more specific. Alternatively, if you provide something that doesn't match anything, it will also say, hey, I can't find that at all. So it gives you confidence that the thing that you're getting back is exactly what you were looking for, no more and no less. So if we have an example of employee.objects.get with first name of Bob and last name of Marley, then it's going to return exactly that only if we have a single Bob Marley in our fictitious company. Now, I told you earlier that working with a bunch of Bobs, so if we try to do employee.objects.get and only passed in the first name of Bob, then we're going to get this exception of multiple objects returned, which is because it matched multiple rows in the database. And then if we have another Bob that wasn't in our set, and here I'm saying employees.objects.get, first name Bob, last name Saget, then we will get a different kind of exception of employee does not exist. Another method that you will use often is the exclude method. And this is actually an interesting one because it highlights a functionality out of a lot of the query set methods that exist. And that functionality is that query sets will return query sets in and of themselves. For instance, if we have employee.objects.filter on first name of Bob and leave it at that, we would have a query set come back to us. But you can chain query sets together to make another query set. I'm going to extend it on, and beyond the filter, I'm going to say dot exclude last name of Ross. Now, what we should get back are the other set of Bobs that excludes Bob Ross. So that is a useful pattern for filtering out records that you don't want to manipulate at the time. There's another method called update, and as you might imagine, it's for updating records. The nice part about it is that you can update a set of records at a single operation. So if we wanted to, for instance, rename all the Bobs to a more formal first name and more likely first name, frankly, of Robert, we could say employee.objects.filter, first name equal Bob, update Robert. And that will go and find every record that matches the name of Bob and change it to Robert in one single go. There's another thing that might occur, and that's checking that something even exists. And you might want to check that something exists without pulling in all of the data about it, because you're searching for a particular record and you want to report if something's there or not. So we can say employee.objects.filter, first name equal Bob .exists, and that accounts for the condition where there are some number of Bobs in this employee table. And so I'm assigning that to an attribute called hasBobs because the exists method does not return a query set, it actually returns a Boolean value. And then we can use that Boolean value to perform some sort of future logical operation, like if we needed to check if there were any Bobs in our company or not. Another way you might handle this is with a count operation. When you do a filter operation and you pull in a query set that gives you all of the Bobs and then you loop over them, or if you were to call the len function, because a query set is like a list container, if you were to call len on it to get how many there were, you can do that, but it's not very efficient from a SQL query perspective because it's going to fetch all of the data about them. And if you don't actually use any of that data and you're just counting how many records there are, that's pulling in way more data than necessary. So if you did something like employee.objects.filter, first name equal Bob .count, then that is another one that's not going to return a query set. It's going to return an integer value. And the nice part about the count method is that the SQL query that it will issue to the database is a lot more efficient because it's asking the database to do the computation of how many rows match that record and just return that value. So there's less data that has to be transferred over our network, and there's just a lot less processing that has to happen in that situation. So if you know you're only going to use the count of something, then you should definitely call the count method. There's a couple more methods that we should consider. There's one called none, and this one's a little strange. It's for a scenario where you deliberately want to get back an empty query set of records. Why would you use this? One circumstance that I've used this in is when I want to do something that has some kind of access control and I want to restrict who can see certain types of data. For example, maybe we have something that is looking at all the employees in this database, and it's an administrative kind of page, and there are engineers and marketing people and all sorts of people that could possibly access this page, but only certain kinds of employees should actually see the data on this page. And in that scenario, you could use the none to do the filtering there. If we have a chunk of code that says employees.object.all, which, as you might imagine, gets all of the rows out of the table and assigns that to a query set, that's good for seeing all the records. But if we have some kind of extra access control that says is a Boolean like is HR for is human resources, we could say if not is HR, then employees equal employee.objects.none. And now suddenly that employee's query set variable is overwritten and uses this none result, which means that it's not going to return any records, regardless of how you filter it. And finally, on our tour of query set model methods, I think it's useful to know about first and last. And these are circumstances where maybe you're trying to match a particular thing and ordering matters. So let's say we want to match on Bob, and we want to match by their last name. If we have employee.objects.filter first name equal Bob, and then we chain that to .orderBy because there we want to tell the SQL query to order the rows that come back in a certain way. We want to order by last name, and then we say .last. Then we're going to get a single value returned back to us, which I've assigned to a Bob. If we print on that and look at what the last name is, we'll see that of the 4 Bobs that we've worked through in our examples, that we would get Bob Ross back because that is the last name alphabetically. So that's a smattering of query set methods that I think you might find useful as you interact with Django. Again, if you want to read more about query set methods, there are others that are a bit more specific to circumstances. You can go read the Django docs, and they do a good job of teaching you all of them. But I wanted to give you crisp, concrete examples that you could see each one in action using a pretty simplified model to get a good feel for that. These examples are present in the show notes, and you can check them out. There should be a link to the show notes in the episode, and I'll mention them at the end of the episode as well. In our discussion so far, we have talked about a very boring table at this point. It's an employee table that has 3 character fields, and I did that on purpose. I was deliberate about using character fields just so that we wouldn't get bogged down in the differences, and it gives you time to absorb the material without thinking about the variances that can be within a model. But there is variances that can be in models. You can store different types of data in a database, and Django has different model fields that wrap up those different types so that they can store them appropriately for the database that you're working with. These model fields are going to match up very closely in many ways with the form system that we've already seen. The form system has a set of fields that it works with, and the model fields are similar because a lot of the times what you're asking for from users in a form, you're going to want to store in a database. So there's a lot of corresponding values between what exists in a form field and what exists in a model field. That's not 100% true. There are some fields that only exist in models and vice versa, but there is a lot of similarity. So we see stuff like character fields, Boolean fields, date time fields, and other similar types that we saw in forms. They exist here so that we are able to store them. Let's talk about some of the attributes that can exist on model field that you might find yourself using when you want to define your models. Let's start with default. When you create a model instance, you may not want to have to go through the work of providing values for everything. Maybe it doesn't even make sense for you to provide values for everything. Maybe everybody's supposed to start out with the same kind of stuff. And so in order to provide the ability to not specify everything every time, there is a default option that exists on all of the field types. The default can be either a singular value that matches the data type that you expect to store, or it can actually take a callable, a function that can provide that value at runtime. Let's consider an example. We've got an application models py file, and we're going to import random, and we're going to import models from Django.db. And the name of our model is going to be a Dungeons and Dragons character. It's going to be a subclass from models.model, and it's going to have two different attributes on it. The first attribute on the model is name, and it's a models.character field, and that needs a max length attribute, so we're just going to give it a value of 100. And we're going to give it a default as well. And the default here is going to be Conan, like Conan the Barbarian. It's going to get a second field as well. And this is going to be a strength attribute. So it's a models.integer field. And it's going to have a default. And this time the default is going to be a strength generator. It's the name of a function. And I'm not calling a function, but I'm giving the function as an argument. So I skipped over the strength generator because it wasn't going to make sense at the time, but above the model definition, there is this strength generator function, and it's returning a random integer from 1 to 20, because this is a Dungeons and Dragons character, and if you know anything about D&D, you know that there are attributes that are characters given that usually go through 1 to 20. So the nice part about this callable is that when a model is generated, it will be given a random strength value. And if this was a true Dungeons and Dragons character, I suppose there would be dexterity and charisma and all the other attributes that go along, but I didn't want to put all that extra stuff in there. So it's just an example of the default can be a literal value, or the default can be a callable that can vary at the time of creation. We can also add an attribute to a model field called unique, a Boolean field, and it is what it sounds like. When you set the unique attribute, you expect that field will be the only row in a table that matches that condition. So if you had a model that had a name on it, that was a character field that was unique, then you could only have one person named that way, if it was a kind of a person class. That's not very useful for names. I don't know many circumstances where people would not have name conflicts, but there are plenty of other possibilities of models where you want to have a unique name. Maybe it's an order number or some kind of identifier that must be unique between each row, or else you're going to have problems. So adding a unique attribute to it is very handy, because what it does is it puts a constraint in the database. So if the database encounters any data in the table that is not unique, then it can raise an error condition and say, you're trying to add something that is already present because you have declared that this value must be unique, and it's not. Another common attribute is the null attribute. Null is a way to represent nothing in a database. Null is a special value, and it exists because sometimes you may not have the data. And the distinction between not having data versus having an empty value is important. And that's a little fuzzy to get initially, so I'll try and make it a little bit more concrete. Let's say you have a person model, and you add an integer attribute on it that says number of children. There's a grand difference between setting that value to null versus setting it to a value of 0. In one case, you're saying, I don't know how many children this person might have. Null. The answer could be 0, it could be 1, it could be 10. We don't know. Setting it to 0, on the other hand, is definitively saying this person has no children. And that is a very good distinction to make. While null is not something you always need to represent, sometimes there will always be a known answer. In circumstances where there isn't a known answer, having the ability to insert nulls into your database is sometimes the right choice for data modeling. A word of caution, though, is that nulls do add extra checking, extra state that you have to consider, because what might be some data type may come back as none when you don't expect it. If you have an integer field that has null in it, you could have none. And so if you are doing logic in your code and you're adding that attribute to something else and it's none, you're going to probably get some kind of none type error. So watch out for null. Use it when you need to, but just be aware that it does have its side effects that will have to be dealt with in your code when you handle that. Another attribute that often goes hand in hand with null is blank. Blank is there as not so much as a tool for the database, but it's more of a tool for Python code. It allows form validation for a field to be empty. And you might need to use this when you want to permit nulls, because let's say you have a form that you don't have the value for number of children because someone didn't supply it because they're concerned about privacy or whatever, and you want to be able to save that value. If you use some of the automatic generated forms then and don't specify blank of true, then it's possible for that form to reject it because it could say, I need a value for this. So by adding this blank equal true attribute, you allow some of these auto-generated forms that Django can produce to also permit null to be accepted as a value. We're going to see this more on the Django administrative site that we'll talk about on the next episode, but it was a good one to bring up that you should be aware of. Another field type attribute that can go in is the choices attribute. We saw the choices in forms, and it also applies to model fields. It's a good way of constraining what is permitted to go into a particular field, because Django will add some validation that will make sure that choices are of the right choice. And finally, in our walkthrough of attributes that are useful on fields, you can add help text. Help text is good for clarifying the purpose of a field, because you may not remember what a field does if you've worked on a project that is long enough or old enough or big enough, or maybe you're working with a team and you need to communicate with other team members that you have. It's valuable to add help text to a field to describe what it is, especially when it's a non-obvious kind of field. I've got an example in the show notes of a policy model, and I just made up a silly Boolean kind of field that is called is section 987.123 compliant. And I don't know if you're like me, you should be because it's totally fake. You would have no idea what that field represents. So I added help text in the example to describe the reason for that field existing. It's very good if you are working with industries that might have extra kinds of data. For example, I work in healthcare right now, and there's all sorts of different kinds of fields that need to exist for legal reasons and healthcare reasons, but you're not going to remember what all of them are for necessarily because they can be very domain specific. So using help text on a model can help you in the future or your teammates. We've talked about query sets and managers and some useful methods on them. Talked a little bit about model fields. The full reference for model fields, of course, on the Django project documentation, but we did look at some attributes that are common to the fields that are useful to know about. I do recommend you go look at the documentation to see all the field types that are available to you. But let's get back to the subject of what makes a database relational. In our example so far, we've talked about a single table. It's been an employee table that has a few basic attributes on it. And in that scenario, there's nothing really relational about it. It's a single table. It doesn't relate to anything. But that doesn't do much in the world. There's more that can go into a database. Sometimes you need to model other kinds of data. Let's think about phone numbers on an employee table. What if you need to track a phone number for your employee? Maybe you need to be able to call them when they are out of the office for whatever reason, or maybe they need to have office phone numbers, or maybe they are doctors and need to have pagers. I don't know. There are lots of reasons why you might need to have phone numbers. So how can we model that on an employee table? Well, one possibility is to add the phone number directly to the employee model. There's a really big limitation to this, though, and that's that you can only easily do one phone number. As soon as you do multiple phone numbers, you're going to have some questions that are going to come up. Let's think about what the multiple phone numbers in a single table scenario looks like and see what's wrong with it or what could potentially be wrong with it. There's always that circumstance where maybe it works out for you, but it's not going to be common. We have an application models.py file, and from Django.db, import models like normal. We have our class that's an employee. It is a subclass of models.model, and like in our previous examples, it has the same 3 attributes of first name, last name, and job title, and they're all character fields. In this version, though, we're adding 2 new fields to the bottom of that list. One is phone number 1, and one is phone number 2. They're both character fields. They both have a maximum length of 32. This does work to track phone numbers. You could work with this system, but there's some problems with it. As it's described, there's no way to track the type of data. So is phone number 1, is that a home phone number? Is it a cell phone number? Is it a fax number? Is it a pager number? Is it a work office desk number? We don't know. The same holds true of phone number 2. And they could be interchangeable. For one employee, they could be office and home phone, and the second employee, for whatever reason, be flipped. So that's not great for determining type, and it's just not very useful for tracking all the different types of numbers. There could be an employee that has more than 2 numbers. What do you do in that scenario? Do you go and add a third, a fourth, a fifth, a sixth number to that employee table just to specify the needs of that one employee when most other employees only have 1 or 2 phone numbers? That would be kind of silly. So what we do instead is break this apart into 2 separate models. We're going to work with a models.py file. We're going to have the same employee table as before, but we're going to take off phone number 1 and phone number 2. Those things go away. Instead, we're going to create a new model. It's going to be class of phone number. It's going to subclass from models.model, and it's going to have an attribute of number, which is a character field with a max length of 32. And then we're also going to add in an integer field of phone type. Phone type is going to take a choices attribute, which will be a list of phone types. It's a set of tuples of 1 and mobile, 2 and home, 3 and pager, 4 and fax, just to be able to specify some. And we're going to give a default value of 1 so that our phone type is a mobile phone. We've got 2 separate tables in this circumstance, but we haven't linked them together in any way. It's possible right now to create an employee and to create a phone number, but how do we connect the phone number to the employee? To do that, we use a relational field type. Now we're going to get into the relational aspect of the database. And that field type is called a foreign key. So what we're going to add to the phone number class that we just discussed is an employee attribute, which is going to be a models.foreign key. And the first argument to foreign key is the name of the other table that you want to relate to. So it's employee. And the second one is a specific parameter called onDelete, which is models.cascade. I'll speak briefly to the cascade part. It's not really important, super important to today's discussion, but the cascade is to describe the behavior of what happens when an employee record gets deleted, because there's an association between this particular phone number that might be created and any employee, and what should you do about it. You can learn more about the onDelete behavior in the Django docs. That's about as deep as we need to go into it right now. So we don't understand how this works yet, though. How is the relationship actually formed? In order to understand that, we need to understand keys, which we have not talked about yet. When you create a Django model, we added some specific data that accounts for the data that we care about. But there's another field that Django added under the covers that is also important, and it is added through something called an auto field. And I've got it in the show notes, but it roughly translates to what Django will include in your model by default. It's an ID attribute, which is a models.auto field and with a value passed in, an argument passed in of primary key equal true. So this auto field is an extra column that gets added to the database table. The job of this column is to give a unique number to each row that gets added. It's going to use database technology to be able to increment that number for every row. So when you create a new record in your database, the ID value, the ID column, will be given a value and it will be unique. And this identifier is called the primary key. And the primary key is really powerful and really necessary in enforcing the relational aspects of databases and database tables. In our example way back when we had Tom Bombadil as the first employee, for instance, and he was truly the first employee of that table, the first row, the ID would be auto-assigned to a value of 1, and everyone after that would be given 2, 3, 4, etc. So now that we understand that there are primary keys, there is some kind of identifier that is attached to each row, we are equipped to understand how foreign keys work. A foreign key works by storing the key of a related record in that new record type. Now that's a mouthful, so what am I talking about? We have the employee foreign key on our phone number. How do we know that a phone number is associated with a specific employee? We know by taking the primary key and storing it with the phone number. So let's look at an example to try and make this as concrete as possible. If we get Tom Bombadil out of the employee table, so that's employee.objects.get, and we have a first name of Tom, last name of Bombadil, we should get the single employee instance that represents Tom. So we pass Tom to the phone number class. So phone number.objects.filter with an argument of employee equal Tom is going to return a query set of phone numbers. The query for phone numbers, if you look at it, the SQL query, is a select where it's selecting a bunch of data from the phone number table, and the important part is the where clause that is on this SQL query. It is where application phone number employee ID equal 1. So as I mentioned a moment ago, Tom is assigned a primary key value of 1. If we store that value in each row of the phone number, then we can find all of Tom's phone numbers, because that should only match for phone numbers that are associated with Tom, because, as I said, primary keys must be unique. So there's only employee that can have it is Tom. He's the only one that gets value 1. By storing the primary key on this other table, that's the tool that gives us the ability to look up the phone numbers for a specific user. There's another important relational type that we should consider, and it's called a many-to-many field. And this one's a little bit more complicated, so I hope you can bear with me. I'll try to make an example that makes it clear, but you can refer to the show notes if you need to see more. We're going to think about neighborhoods. A neighborhood can have a variety of different types of residences, but we'll stick with a house because it makes the example simpler, and the last thing you need is more data to consider, especially over audio format. So what we're going to work with is 2 different models. One will be a person model, and the other will be a house model. And what we're trying to figure out how to describe in this modeling scenario is how persons, how people, and houses relate to each other. So what if we tried to do a foreign key instead of a many-to-many field? Let's take a look. If we have application models.py and we have a person model, and just to give it something, we're going to give it a name attribute, which is a character field. We're also going to have a house model, and we're going to give it an attribute as well and add an address attribute. But in addition to the address attribute that gets added, and that address attribute is a character field, we're going to add a foreign key called resident. So resident equal models.foreign key, and it takes the person model as its first argument. And so now we've described a relationship where a house points back to a person. And this kind of works, but isn't quite right, because when you think about this scenario, what it's saying is that a house can only have a single resident. That's the important part. There's a one-to-many modeling that works with foreign keys. So a person could have multiple houses, but that doesn't make a lot of sense in the real world here, because if a house can only have one resident, then that means that a person could own multiple houses, but could only be in one of them at a time. And a lot of people live with others, and so it just doesn't make a whole ton of sense. Okay, let's think about a foreign key relationship that flips this on its head. So now we're going to flip things. We've got another application models.py file, and this time we have a house model, and it's got an address, but we are going to skip the resident foreign key that we had before. Instead, we're going to have a person model, with its name attribute that it had before, but now we're going to attach a house foreign key to the person. So in this version, a house can have multiple residents. And that's pretty close. Most people only live in a single house, but it still doesn't fully model the real world. Because while it's true that most people only have a single house, it's not the full truth. There are people that own multiple homes. They might have a beach house. They might have a cabin in the woods. They might have any kind of other house in addition to their primary residence. So it doesn't fully match the real world too. And the problem is that you can have many on one side of a relationship and many on the others. In other words, a person can be part of multiple houses. They can own multiple houses, but simultaneously, a house can have multiple residents. So you have to model this many-to-many relationships. So how do we do this? We do it with a many-to-many field is the answer. So in our final version of this, we've got the person model, and it has the name attribute again. We have the house model, and it has the address attribute again. But this time we're going to say residence equals models.many-to-many field and point to a person. Okay, we need to think about this because there's some interesting stuff going on here. How does this work at the database level? That's the thing that we need to consider. When you have a foreign key, I said that that worked by storing the primary key of a different table's row in your row. So a phone number had Tom Bombadil's primary key in that row to identify that phone number as his. But you can't store multiple foreign keys in an individual foreign key row. And the reason for that is kind of baked into how the database column works. It can only hold a single value of that type. And what that means is that a many-to-many relationship cannot be modeled in the same way by just storing a list of identifiers in that particular column. So if you can't store a list in a placeholder, then how does the database do this? How does a database have many on one side and many on another side? Well, the way to do it is an interesting trick, not a trick, but an interesting technique, I guess. And that's to introduce a third table. The third table is going to join the values together. It's going to have a mapping of both. Let's make this as clear as we can by considering what that third table has. The third table has 2 columns in it by default. There's a way that you can, in Django, control this third table and add more columns, but we're going to set that part aside. At minimum, it has 2 columns. It has the foreign key of one model and the foreign key of another model. So we want to think about a minimal many-to-many relationship that will model everything that we care about. And so let's think about a scenario with 3 people and 3 houses. And so we've got 3 people records, and their primary keys are going to be values of 1, 2, and 3. You can see this visually in the show notes if this is confusing, so keep that in mind. We've also got 3 houses, and we are going to give them primary key values for the purpose of this example, values of 97, 98, and 99. So we're going to assume some conditions about these people and these houses. So we're going to say that the people that have primary keys of 1 and 2 reside in house with primary key 97. Conversely, we're going to say that the person with primary key 3 owns house 98 and 99. Hopefully you can see it's how we're modeling many-to-many here. Modeling many people owning a single house, or also modeling one person owning multiple houses. So in this joined table, we have the two columns, and in order to make that work for the relationship that we just described, there are going to have to be 4 rows in this table. The first row is person 1 and house 97, because person 1 resides in house 97. The second row is person 2, house 97, because the second person also resides in house 97. And then we have the third row, which is person 3 with house 98. And then finally, the fourth row is person 3 with house 99. And you can see there's kind of a symmetry that goes between these that shows how multiple primary keys can be repeated across rows. And that's how it's captured to show who has what and who lives where. We now have our many-to-many field. It creates this intermediate joining table that allows us to model both sides. And how do you work with this? That's the important thing to know. If you have the scenario where you have this kind of unique relationship, then how do you use it? Well, we had that residence attribute added to the house model. That resident attribute is got a certain type. It's a special type of manager called a many related manager. And it has knowledge of how to do manager operations and provide query sets and do the standard kind of things that you get with a manager. And we'll see that in an example. That's how to get residents from a house. But how do you go the other way? If you have a person, how do you get their houses if they have multiple of them? Well, that's a little bit more mysterious, but Django works by providing an attribute that gets added by default, and it takes the name of the model and adds an underscore set to it. So by adding the residence many-to-many field to the house model and telling it's related to the person model will have a house set added to that class in the reverse order. You can specify the name if you wanted to call it something different. You can use an attribute called related name. So let's say if you didn't want to call it house set, you could add related name equal houses, and that would give you a more natural name to call the other side. So if we want to access these, this is what it would look like. If we've got a house, and we can get any old house. So I'm doing house.objects.get, and I'm saying the address is 123 Main Street. Then if we want to get the resident of that house, we would say for resident in house.residence.all. And then we can print out whatever, we can work with it, whatever we want there. The thing to key in on is the use of the .all method in order to actually get all of the people that were associated with the house. Likewise, we can get any houses related to a person. So if we're going to get a person, we can do person.objects.get, and we'll say name equal Joe, because it doesn't really matter. And then we'll say for house in person.houseset.all. So very similar, but you can see that this time we're using the auto-created attribute that came from Django. Having an understanding of foreign keys and many fields is really important when you need to model something that is more complex in your problem domain. You can work with simple tables and get pretty far doing that, but as soon as you find yourself in this bind where you have this more complex relationship, foreign keys and many-to-many fields are going to be the tools that you reach for. So we've reached the end of this discussion on models and managers and query sets. We've seen how you can save information into a database. We've looked at the different methods that are available to managers and query sets to ask for information out of the database. We've also considered the attributes that are added to different fields and the different kinds of fields you can work with. And finally, we've looked at some complex field types to model real-world problems. In the next episode, we're going to shift our attention. We've covered a huge variety of topics, and at this point, frankly, you should have all of the tools to build most of a website. The models, templates, views, URLs, all of the basic building blocks for building a website are there. So we get to turn our view towards the extra stuff that Django has. The whole reason that Django is awesome, or at least one of the reasons that Django is awesome, is that it includes a ton of extra goodies that make your life easier as a developer. And the first one that I want to highlight is Django's built-in administrative tools. So on the next episode, we're going to look at the Django admin site. Full show notes for this episode are available at www.mattlehman.com/DjangoRiffs/7. Thanks for listening to this episode of Django Riffs. You can follow the show at djangoriffs.com. If you have something to share, feel free to reach out to me on Twitter. My Twitter handle is mblehman, or follow the Django Riffs handle to keep up with the show. If you've enjoyed the show, please rate or review on iTunes, Spotify, or from wherever you listen to podcasts. Your rating will help others discover the podcast, and I would be very grateful. Django Riffs is supported by listeners like you. If you can contribute financially to cover hosting and production costs, please check out my Patreon page at www.patreon.com/mblehman. The theme music for Django Riffs is Open Roads, used with permission from Purple Planet Music. I hope you'll join us next time to learn more about Django. Take care.